Welcome to our deep dive into chemical reactions and equations. Chemistry is all about understanding how substances interact and transform. In this video, we'll explore the different types of chemical reactions, how to balance equations, and the real-world significance of these processes. Whether you're preparing for exams or just curious about the science behind everyday changes, this journey will make complex concepts clear and approachable. Let's begin by understanding what a chemical reaction is and why it's so important in both nature and industry. Get ready to see chemistry in action. Chemical reactions come in various forms, each with its own characteristics. Let's look at some key types. Combination reactions involve two or more substances forming a single product, like Ka and Co2 combining to make Ka3. Displacement reactions occur when a more reactive element replaces a less reactive one, such as magnesium displacing copper from copper sulfate. Double displacement reactions involve the exchange of ions between two compounds, resulting in new product. Decomposition reactions break down a compound into simpler substances, while redox reactions involve the transfer of electrons. Understanding these types helps us predict and control chemical changes. Let's clarify the difference between displacement and double displacement reactions. In a displacement reaction, a single element replaces another in a compound, like magnesium reacting with copper sulfate to form magnesium sulfate and copper. In double displacement, two compounds exchange ions, such as barium chloride reacting with aluminum sulfate to produce barium sulfate and aluminum chloride. These reactions are crucial in industries for extracting metals and purifying compounds. Recognizing the difference helps in predicting products and understanding reaction mechanisms. Photosynthesis is a classic example of a chemical reaction in nature. The balanced equation is 6Co2G plus 6H2OL right ROC6812O6 Ac plus 6O2G in the presence of sunlight and chlorophyll. This process is endothermic, absorbing energy from sunlight. Other reactions can be classified as exothermic or endothermic. For example, electrolysis of water is endothermic, while burning natural gas is exothermic. Decomposition of calcium carbonate is endothermic and burning magnesium ribbon is exothermic. Understanding these classifications helps us grasp energy changes in reactions. Oxidation and reduction are fundamental concepts in chemistry. Oxidation involves the gain of oxygen or loss of hydrogen, while reduction is the loss of oxygen or gain of hydrogen. For example, when iron reacts with oxygen to form rust, it's oxidized. In another case, hydrogen reduces copper oxide to copper. Redox reactions combine both processes, with one substance oxidized and another reduced. These reactions are vital in batteries, metabolism, and industrial processes. Recognizing oxidation and reduction helps us understand how energy and matter flow in chemical systems. Corrosion is the gradual destruction of metals by chemical reactions with their environment. The corrosion of iron, known as rusting, is a serious problem because it weakens structures and machinery. Rust can be recognized by its reddish-brown color. Preventing corrosion involves painting, galvanizing, or using protective coatings. Rancidity, on the other hand, refers to the spoilage of oily foods due to oxidation. It can be prevented by storing food in airtight containers or adding antioxidant. Both corrosion and rancidity highlight the impact of chemical reactions in daily life. Balanced chemical equation has equal numbers of each type of atom on both sides, satisfying the law of conservation of mass. Balancing equations ensures that matter is neither created nor destroyed during a reaction. For example, the reaction between calcium hydroxide and carbon dioxide forms calcium carbonate and water, and must be balanced to reflect the correct proportions. Mastering this skill is essential for accurately representing chemical processes and for solving problems in chemistry. Chemical reactions are everywhere, from the rusting of iron to the fizz when water is added to quicklime. In industry, reduction processes are used to extract metals. In daily life, the color change when an iron nail is dipped in copper sulfate solution is a visible sign of a chemical reaction. Chips packets are filled with nitrogen to prevent rancidity. Understanding these examples helps us connect theory with practice and appreciate the relevance of chemistry in our surroundings. Wrap up, we've explored the main types of chemical reactions, how to balance equations, and the importance of oxidation, reduction, corrosion, and rancidity. We've also seen how these concepts apply in real life and industry. Remember, chemistry is not just about memorizing equations, it's about understanding the changes happening all around us. Keep practicing, stay curious, and you'll find chemistry both fascinating and useful in everyday life.